Hello, for today's video lecture we're going to be talking about bodies. So what is a body, at least in terms of engineering mechanics? Well, a body is going to be any object or kind of collection of connected objects that we want to analyze as a whole. So a body can really be pretty much anything. It is the object of analysis in our engineering mechanics problems. So it can be something like a baseball, which is a pretty kind of consistent piece, or we can talk about something like a bridge. Now a bridge depends on how we define the body. We could look at individual members, individual pieces of the bridge, and each one of those is a body. Or we could look at this whole connected structure. This whole thing could also be a body. So really, a body can be pretty much anything. Some of the important things to understand about bodies, though, are the types of different bodies. So there's two important distinctions that we're going to want to make. Number one is rigid versus deformable bodies. We'll talk about that here in a second. And the second is going to be particles versus extended bodies. Alright, so going back to the first one, rigid versus deformable bodies. The distinction between these two types is a rigid body. We're going to assume that it does not deform when loaded with forces. It stays perfectly rigid. And it doesn't kind of change shape. A deformable body, on the other hand, when loaded with forces or moments, is going to bend, stretch, change shape slightly. So everything technically is deformable, but some things, like a chair or a table, deform so little, we basically treat them as rigid bodies. All right, so looking at examples of this, so kind of a car moving down the road, if it's just kind of working in its normal fashion, we consider that something like a rigid body, even there's little pieces that can kind of move relative to one another. Same thing with our bridge. As a car goes over it, it deforms so little that deformation is kind of insignificant in most of our kind of statics analysis. For deformable bodies, we've got kind of a car over here that's hit a tree. Now when we're analyzing this, if we hit a tree, there's now significant deformation here in the front of the car. Our car is going to be a kind of rigid body as it's just moving down the road, but if we in a crash, we need to treat it like a deformable body. Or something like this pair of scissors. Each of those pieces in the pair of scissors is going to be rigid. It's not going to move a whole lot. But we've got a kind of a connection here. This rivet here in the middle allows the two pieces to move independently. And so the entire body that would be this pair of scissors is not a rigid body, it's a deformable body there. Alright, so that is one kind of distinction between rigid and deformable. The other distinction we need to pay attention to in statics is going to be particles and extended bodies. So this distinction for particles and extended bodies, a particle is assumed to have all the mass concentrated at a single point, whereas an extended body has mass distributed over some volume. Again, everything technically is in this second category. Everything takes up some space. It's not just a little black hole, a little tiny piece all concentrated at one point, but depending on the situation, we approximate a lot of things as particles. So looking at examples of where we put different things in different categories, something like this baseball, if I hit it with a bat, I basically treat this as a particle. I'm not too worried. It's pretty concentrated in terms of my problem as it flies through the air. Something like a box, if I'm pushing it along the surface, so the box is going to have some mass distributed over an area, but the distribution of that mass is not particularly important if I'm just looking at force equals mass times acceleration for my box kind of sliding across this surface. For extended bodies, if I've got something like a crowbar, and this gets into something I definitely cannot count as a rigid or a particle. So the crowbar, the whole reason it works is because we've got kind of this moment, this bending moment, and anytime we have to deal with moments, we definitely have to deal with extended bodies, and so that's the whole reason this works, is we've got that kind of twist in our body. And something like this bridge, we've got kind of the bridge here, and I've got supports on either end. It's going to be a different problem if I move those supports one way or another because of the moments involved in the problem. So if we deal with moments, we need to treat it as an extended body. If we can kind of ignore the moments, we can treat our situation like a particle. All right, so that's all I have for today on bodies. Thank you for watching, and I hope to see you again.